Okay, so today we are obviously factoring. We're going to be factoring polynomials today. So the first technique that we're going to go over, that you already did it in the warm-ups today, and you guys did it beautifully, is factoring four terms. You've only ever dealt with trinomials. Trinomials were the biggest that you ever did back in Math 2. Well, in Math 3, you're going to have trinomials, but you're also going to have these ones that have, it's a polynomial with four terms. 4 is an even number, which allows us to break things in half. So you just split it in half, but try not to cover up the sign. There's a minus sign, so notice I put my little break, my squiggle, right before that minus sign, because I don't want to cover it up. I need it. It's a connector sign. I don't want to lose it. And a lot of times students forget that and they draw their squiggle over it and then they lose it. All right, and then on the left of the break, we need the greatest common factor. What is the greatest common factor on the left? 2x squared, right. Remember, factoring is just a fancy word for dividing. We have to divide out a 2x squared. Can someone tell me what's left in the parentheses? X plus 5. All right, and then that minus sign that's after the break, I'm going to draw a little arrow. That is the sign that always gets lost. Students always lose it or they forget to write it. That is important. We need it. All right, and it also tells us whatever we factor out on the right is going to be negative. What's the GCF on the right? A 3, so it's going to be a negative 3. When we divide out a negative, remember a negative divided by a negative is positive. So this should have a plus sign in the middle. So negative 3x divided by negative 3 is just a positive 1x. Negative 15 divided by negative 3 is a positive 5. Right, and this is perfect because if whatever we have in the parentheses is the same, first of all, that means we're doing it right. Second of all, if they're not the same, it could mean that you're doing everything right, but it might not be factorable. So just if you're doing a problem like this and you get stuck, it might not be factorable if you end up with these two not being the same, because that can happen, and you're going to see that happen this year. But this one is factorable. So x plus 5 is one of the factors, and then we need the leftovers, like you do for leftover night for dinner. You slap them together. So 2x squared minus 3. That's why that connector sign is so important. That's how you know you're going to connect the leftovers together, is with that sign. And then you have to check, can we factor anything else? Yeah. Well, this is a difference, so you might need to check if it's a difference of two perfect squares. X squared is a perfect square, but is 2 a perfect square? No. Is 3 a perfect square? No. So we're done. We can't factor it anymore. So that is our final answer. Okay. All right. You guys try number 2. Try number 2. All right, did you guys get it? What'd you guys get? Yes. 4x plus 7 and x cubed plus 1 is correct. All right, so again, if you didn't get that, you break it in half because we got 4 terms. and you factor each side. So let's see, what's the GCF on the left? X cubed, right, that's the greatest common factor. So then we're left with a 4x plus 7 in the parentheses. And then don't forget to bring down the connector sign. And 4x and 7 have nothing in common. But what is the one number that's in common with all? 1. Because you got to put something. So sometimes it's as simple as just a 1. All right, and then we have the same expression in the parentheses, which means it is factorable, and we're doing it right. And 4x plus 7 is one of the factors. And then the leftovers are the x cubed plus 1. You slap them together like you do for dinner on leftover night. And there it is. Okay, good job. So factoring 4 terms, super simple. So anytime you see 4 terms, this should be the first method that you try. Okay. All right, next method is factoring trinomials. Factoring trinomials. So trinomials means that there are 3 terms. Now, you factored trinomials back in Math 2, and we talked about this a little bit when I was going over the warm-ups. There were hard trinomials and there are easy trinomials. When we talk about a trinomial, we're talking about standard form of a quadratic typically. ax squared plus bx plus c. The ABCs, right? We need the ABCs. Not just for quadratic formula when we're solving. We're just factoring today though, but we do need them for the product sum. So for number 3 is something that I would call a hard trinomial. It's hard because the leading coefficient is not a 1, it's a 3. If at any time it's any number bigger than 1, it's a hard trinomial because we have to go through those extra steps to factor it, okay? So the product, so now that you have it in your notes, is A times C, and the sum is whatever the B is. And the ABCs come from the standard form of a quadratic. Okay. All right, so first of all, what's the product going to be? -9. And what's the sum? -8. So I need 2 numbers that multiply to -9, but also add up to -8. -9 times 1, right? -9 times 1 equals -9. -9 plus 1 equals -8. These are the droids I'm looking for. All right, so then we take the middle term. The middle term is the -8x, so circle the -8x. And we need to replace it with the new numbers, the product sum numbers, because we know that they work for this situation. They satisfy the product and the sum. So we're going to take that -8x and we're going to replace it with the new numbers, but it's got to add up to a -8x. So the -9 and the 1 need to have an x attached to them. So -9x plus 1x is what we need to replace it with. Okay. All right, so let's rewrite it. So we're going to have 3x squared, but instead of the -8x, we're going to have -9x plus x minus 3. And now, just like example 1 and example 2, we have 4 terms, and we can break it in half and factor each side. What is the greatest common factor on the left? A 3x. So we're going to factor out a 3x. Remember, factoring is just dividing, and when you divide out a 3x, what's left inside? -3. Bring down that plus sign because we need that connector sign. And x and -3 have nothing in common, but what is the one number in common with all? A 1. We have to put something. And we've got x minus 3's in the parentheses, which means it is factorable. We are doing it right. And x minus 3 is one of the factors in the answer. The other factor is going to be what? 3x plus 1. The leftovers, slap them together. And there we go. And there is our answer. X minus 3 times 3x plus 1. Now, if you get these in a different order, that's okay. The 3x plus 1 can go first if you want to. It doesn't matter. Order doesn't matter when we're multiplying. It is commutative. That's what that means when order doesn't matter. All right, so number 4 is also a hard trinomial because the leading coefficient is a 2. So you're going to do product sum. So you guys try that one. Let's see how far you can get. If you get stuck, that's okay. I'm still going to go over it. But let's see if you guys can do it.
Why did she add one on the last one? I think we need to clear
Did you guys get it? Wait, okay. You guys have it now? What's the product? And the sum? What two numbers? 4 and 3. And it doesn't matter the order you put them in. 4 times 3 is 12. 4 plus 3 is 7. These are the droids I'm looking for. So then you do the replacement. So you got to replace that 7x with the new numbers. But instead of 7x, we need to use the numbers that work, but they have to have an x attached to them. So 4x plus 3x. This is what I'm replacing it with. All right, so then when we do the replacement, we're going to have 2x squared plus 4x plus 3x plus 6. And now we have 4 terms, and we can break it in half and factor each side. On the left of the break, what's the GCF? 2x. And what's left inside the parentheses? X plus 2. Bring down that plus sign, the connector sign. And on the right, what's the GCF? A 3. And what's left in parentheses? X plus 2. Perfect. Those are the same, which means it's factorable, and we're doing it right. So now we just have to finish it off. One of the factors is an x plus 2. The last factor are the leftovers. What are the leftovers? 2x plus 3. And there it is. Not too bad. I hope it's not too bad for you guys so far. Number 5, some of you might have started working on it already. That one is not a hard trinomial. It's actually what I call an easy trinomial because the leading coefficient is what number? A 1, right. So this one I call an easy trinomial. So for the easy ones, you just have to find the product sum numbers and pop them in. So I still need to do product sum, but you don't need to do the whole replacement part. You can, it'll still work, but it's not necessary. You can get there faster if you just find the numbers. So let me show you. So for the product, what's the product? -20. And the sum? 1, yeah, because the coefficient on the x squared is a 1. So I need 2 numbers that multiply to -20, but they also add up to 1. What numbers? 5 and 4. But one of them has to be negative. Which one? The 4, right, because 5 minus 4 equals 1. Those are the droids I'm looking for. They satisfy the product and the sum. But I don't need to do the replacement when it's an easy trinomial. All we have to do is set up your 2 empty parentheses. okay? And now I need to figure out what kind of x goes in the front. So how can we split x to the fourth equally? X squared. So x squared and x squared. And one of these has to have a positive 5 in it. It doesn't matter which one. And then the other one has to have a minus 4 in it. But we're not done yet. Because x squared minus 4, you also learned these last year, is a difference of two perfect squares. So we can still factor that one. We can't factor the x squared plus 5. That one's done. So just bring it down. It's got to come along for the ride. But x squared minus 4, difference of squares, always factor down to two binomial factors, but one with a plus and one with a minus. Anyone know what goes inside? X plus 2, x minus 2, right. Because both the x squared and the 4 are perfect squares, so we could split them equally, okay? And now, this is fully factored, so now it is done. It is done. All right. And there's factoring the trinomials, okay? All right, flip it over to the back. And speaking of difference of squares, there is difference of squares, but we're gonna just take it up a notch to the Math 3 level. All that really does is up the numbers. The numbers get a little bit higher. Sometimes they'll add two variables in there, but it's still the same thing. Anytime you have a difference of two perfect squares, you're gonna have a two binomial factors, one with a plus, one with a minus, but with the same stuff inside. So, looking at 16x to the fourth minus 25, 16 is a perfect square, x to the fourth is a perfect square, and 25 is a perfect square separated by a minus sign. So this satisfies all the conditions to be a difference of two perfect squares. So it's going to have the same stuff in the parentheses, one with a plus, one with a minus. Anyone have an idea of what's going to go inside? Right. 4x squared and 5s. So 4x squared plus 5, 4x squared minus 5. And then the only other thing we got to check is if the 4x squared minus 5 is factorable or not. Because 4x squared, that is a perfect square. But is 5 a perfect square? No. So then we are done. All right, number 7 is not there, but I'm going to have you guys write it in. So for number 7, I want you guys to do 4x to the 8th minus 64. And here's my hint to help get you started on this one. Always check for a GCF first. Always check for a GCF first. That's going to be my hint for number 7. So give it a shot. Try it out. Let's see if you guys can do it. And then we'll go over it. All right. So let's see how you did. So if we're checking for a GCF first, what is the greatest common factor first? 4. So we could factor out a 4. So we're going to have x to the 8th minus, what's 64 divided by 4? 16. Okay. And this is still a difference of two perfect squares. We could still factor x to the 8th minus 16. As long as the power is divisible by 2, it's a perfect square. And any even number is going to be divisible by 2. So any even power on an x is going to be a perfect square. All right, so the 4's got to come along for the ride. And remember, difference of squares factor down to 2 binomials, one with a plus and one with a minus. So how would we split an x to the 8th though? X to the 4th. And what's the square root of 16? 4. All right. And then we need to check the difference. X to the 4th minus 4. Is this still factorable? Yes, it is. It's still a difference of squares. 4 is a perfect square. X to the 4th is a perfect square. So 4 and x to the 4th plus 4 are now going along for the ride. And we can still factor this. Difference of squares factor down to 2 binomial factors, one with a plus and one with a minus. But how would we split the x to the 4th? X squared. So x squared plus and minus what number? 2. Right. And there it is. And now it is fully factored. And that is our answer there. Okay. All right. So that was differences of squares, which is something that we learned last year in Math 2. But the only thing that takes it up to the Math 3 level is just increasing the numbers and maybe how many times we have to factor in a single problem. Like that was a lot of factoring we had to do there. We had to factor, what, 3 times? All right. This next section, the last section, is sums and differences of cubes. This is purely Math 3. This is a concept you have not seen before unless you've taken this class before, which I don't think anyone in here has. So this is brand new for you. So when we do a sum and difference of cube, that means we have to either be adding. Sum means add 2 cubes together, and difference means subtract 2 cubes from each other. Okay, so we not only have a difference of squares, we have sums and differences of cubes. Okay, but to be a cube, it needs to be to the 3rd power. Okay, so let's first look at there's a formula. It's not really a formula, but it feels like a formula, but it's more like a pattern that we're going to follow. Okay, so when you have a sum of 2 cubes, it's going to go, so like an a cubed plus a b cubed, that would be a sum of 2 cubics. The way you factor them is we need in a binomial a single a and a single b times, and then this next parentheses is going to be a trinomial. It's going to be a squared minus a times b plus b squared. And the key thing, you'll see the formula in a second. It's just a little bit of a formula / pattern. The big thing is the signs: plus, minus, plus, plus, minus, plus. So when it's a sum of cubes, this is how we're going to handle it. Okay? All right. For the difference of cubes, so I'll put difference over here. I'll put diff for difference. Same thing, except we're subtracting. So it's going to be having like an a cubed minus a b cubed. Okay? Well, same sort of thing. Since I'm subtracting in my binomial, I'm going to have a single a minus a single b times a squared plus a times b plus b squared. So it's the same setup as the sum, except the signs are different. Instead of plus minus plus, it ends up being minus plus plus. Okay. So using this is not that bad, and these aren't formulas that you're going to ever need me to provide to you. They're patterns that you're going to use, and you should know them as you're using them. Okay, you'll get to know them. All right, so let's do number 8. Number 8, we have x cubed plus 27. So this is a sum of 2 perfect cubes. So I need to find what a single of each of these is. Well, x to the 3rd is a cubic because it's to the 3rd power. So a single x would be like my a value. Okay, so that would be my a single x. And then for the 27, I need 3 of the same number that multiply and equal 27. What number is it? 3, yeah. 3 times 3 times 3 is 27. So 3 is my b. So x is my a and 3 is my b. I don't want to put a and b underneath there because then I don't want it to be too confusing. Just remember, these are the singles of these cubics. So they're my A and my B. Okay, so for this factorization, my first thing is A plus B. Well, A is X, B is 3, so X plus 3 is my first binomial. Then for the trinomial, I need in the formula an A squared. Well, I have to take X and square it. Well, that's easy, it's just X squared. And then it says minus AB, so minus, and then A times B, X times 3 is a 3X. And then in the formula it says plus the B squared. Well, our B is a 3. What is 3 squared? So plus 9. And then that's it. That trinomial, x squared minus 3x plus 9, no matter what it is, anytime you are factoring a sum or difference of cubes, this will not be factorable. And even if we check it right now, two numbers that multiply to -9 and add up to -3, there is no such thing. There's no combination of numbers that multiply to 9 and add up to -3, so it's not going to be factorable, and it never will be for those. Okay, so at least knowing that is kind of nice. Where's my lime green? Okay, all right, and then number 9 is a difference of two perfect cubes. Okay, so first of all, do you guys see a GCF? Yeah, what is it? 8. Let's factor out that 8. Always check for a GCF first. It makes your lives a lot easier. So that'll be an x cubed minus, what's 64 divided by 8? 8, yeah, 8 times 8 is 64, right? Okay, so 8's going to go along for the ride. That's okay. We need to find the single of each of these cubes. Well, the single of an x cubed is just x, but what's the single for an 8? A 2, because 2 times 2 times 2 is 8. 2 to the third power is 8. So x is my A, 2 is my B. We're using the difference of cubes formula because it was a difference. They're being subtracted. So the first thing is A minus B. So that's going to go x minus 2 in the parentheses there. And then the next part of the little formula says A squared. Well, that's easy. It's just x squared. And then plus, it says A times B. Well, x times 2 is what? 2x. And then plus the B squared, well, that's just a 2. So 2 squared is 4. Oh, and I almost forgot to move my 8 down. Put an 8 out front. That's still part of it. Okay, we factored it out from the beginning. And there is the correct factorization. All right. So it's not so bad. Once you understand the pattern and you use it, it'll stick. But you got to use it in order for it to stick. So we've got about 11 minutes left of class, or 10 minutes left of class in just a second. There it is, 10 minutes left. Go ahead and turn to the next page. On page 68, that's your homework, numbers 13 through 20. And you guys can get a head start on that. It's good to practice things while they're fresh. And yeah, please no packing up until 3 minutes before the bell. And like I said for the quiz, if you wanted to try for a higher score than what you got yesterday, you absolutely can. But you have to do corrections on the quiz that I gave you, and then bring that to me. It has to be correctly corrected in order to do a retake, though. You already ripped it?
No, but they like